So as I said, this last 45 minutes is just questions and answers, or we can attempt to give answers. So if you have any, you can either put them in the chat window or you can unmute. Hopefully you won't overtalk each other. We can start whenever you like.
You can raise your hand if you think that you don't want to just jump in the discussion together with others.
Good point, raising your hand.
Hey, I'm going to ask a question if that's okay. If you can.
Sure, Sophie, go ahead.
Yeah. So if you wanted to set up a run for a different period in Earth's history that didn't exist beforehand, how would you best go about it? So what I think would be something like find a run somewhere similar and start modifying all of the files that exist. Yeah.
That's right. You want to look, like I said, in our previous papers, see if you can find a run that might be similar to what you're interested in. And if there isn't, then you should probably write me and we can talk about how to do the actual modifications to the files themselves, which boundary condition files have to be changed, and what you have to do to make everything work properly.
Okay, cool. Yeah. And I guess then you have to make sure you get all the right topography files and they all link up and everything's consistent with each other and all of those steps.
Exactly, because you have to get the OIC file right, you have to get the topo-C file, deciding what kind of topography you want for the ocean, which is unknown for most of Earth history, as you know. What the topography is, well, for most of Earth's history, we don't know. We know something about land-sea masks, as you say. Yeah. For example, we have Sturtian topographies that we use, but they're flat, since we don't know, or Sturtian land-sea masks, I should say, with flat topographies, which we use for a variety of things. So we might already have some things that would be very close, for example. And as you know, I've done some future climate stuff that are using some topographies or land-sea masks anyway that are very similar to some in ancient Earth history. And we do have a paleo group, deep paleo group at GISS, and they also have topographies, often for the higher resolution version of the model that they've run using the Earth side of the houses model E as we call it. So that's another possibility.
But they only have above sea surface topography. We have no idea about the bathymetry, so you'll have to improvise there, no matter what.
Yeah. And then what sort of, if you did a run with say a full ocean and atmosphere, how many cores would you run that on? Just sort of
44.
44.
Yeah, so there is the model is parallel across latitudes. So there are 44 latitude bands plus 2 polar caps. You cannot parallelize the polar caps, so you need to run, so the maximum you can get is 44. Beyond that, it will crash, it will not even start.
Okay, I've got one more question. Is how different is the Planet 2 version going to be from the Planet 1 version?
Wow, that's big.
That's a big question.
Yeah. So essentially, there are 3 major pieces in that, and I'm going to be very generic, so you'll have to do some reading for that. The first thing is technical. We support many more configurations rather than the ones that we're supporting in Planet 1. So we have more atmospheric compositions, we have more resolutions, we have 2 radiation schemes, and we have the 3 flavors of the ocean configuration. And we have all possible combinations of them. So there are many options that you can pick one from. Then the second thing is that the model has evolved from so the Planet 1 follows the CMIP 5 version of the Earth model, which was happening around 2006, I think. And then the Planet 2 model has as its base the E2.1 version of the model, which is the CMIP 6, which was frozen like last year. So there is nearly a decade of evolution between one and the other. Maybe I'm exaggerating that. No, it's actually, no, I'm sorry, 2016, not 2006, 2016. So it is, it's like 5 or 6 years of evolution of the two model versions. And these are very substantial. The best way to identify each individual physics change that has happened between the two models is to go into the Kelly et al. Paper 2020 that we have submitted. It's on the GIS website. I will find the link after I'm done talking here to share it with you. And then you can read this paper, of course, not cover to cover, only the pieces you care about, and which describes both the state of the Earth model and the skill, but also the differences since the previous version. So anything you see in that paper that says this is an enhancement compared to last time, this piece is also included in the change from Planet 1 to Planet 2. And then, thanks, Chris. And then the third point, which is a less major, but it is important for some people, is that if you want to do chemistry or aerosols with, or in general prognostic atmospheric composition, then there are additional improvements in Planet 2, which will be, we call it the E3 version of the tracers. It is still E2.1 physics, but it has several additional improvements, both bug fixes and additional functionality that is good for the tracers. And then most people probably don't care about this, but it's one extra thing that Planet 2 has.
Thank you very much. Yeah, that's interesting. So if you, but from the whole sort of model running side of things, what we've just done and looked at would be very similar in the new version to the old version.
Yes, so other than the, I think the single thing you have to worry about is which template run deck to get to start with, because the names have changed very slightly, but it's a different file name. So, and you need to know it. And the moment you know this, unless I am mistaken, this whole tutorial applies exactly.
Okay, great. Thank you.
No problem.
Exactly. And there will be, and COSIS is leading a description paper of Planet 2.0, which we hope will be published, or at least submitted around the time that we release this model. That's our goal. That will tell you what the differences are. So it won't be a rewrite of the first paper. It'll just say, well, this is what we've done differently, and this is what the run decks mean, to give people an idea so that we don't have to write thousands of emails unnecessarily. And
there is, if you want to take a very quick look about science behind that, there is, you can go to the EGU 2020 website and search for my poster. And it contains the first results from that. I can even find the link for this.
Yeah. Okay, any other questions? I guess we've done such a great job, there are no questions.
Oh, while everybody's thinking, I just wanted to mention, I'm not sure if it was stressed during the talks, that on slide 19, actually, the second link to Simplex GIS NASA Gulf website, it basically contains most of the documentation that we have. So, like we were mentioning a lot of Google Docs, and most of those actually are basically referred from that website. So you can just, this is the first basically place to go if you want to look for some documentation of the model. And we will try to put more stuff as it becomes available. At least it will put references there. So.
Yeah, I should mention that there is sort of ongoing development of the model anyway. So we try to fund different projects as we find money for them to do different things. So, for example, one project we're working on now is trying to be able to change the mean molecular weight of the atmosphere as we go through time. That's very important, for example, for doing outer edge of the habitable zone studies where part of your atmosphere is condensing out. If you have multiple condensable species, that's also an item of interest for us. We also want to eventually get an ice sheet model into the model, and we have some ideas about how we're going to go about that. We also are continually working on radiative transfer things. So our next goal for radiative transfer is really to move to hotter temperatures with the model to be able to push the inner edge even farther in and do some other interesting science there. So the model is not static. We're always working on different aspects of it. And I should say that one of the selfish reasons we run this tutorial is that we hope one day that users may consider also contributing to the model. Of course, if you're qualified and have something useful to contribute, it would be great. But anyway, the model is always under development. And again, we are also tied directly to the Earth-based system model. And so we get their updates, but on longer time scales, of course. So as Kostas mentioned, Planet 2.0 is tied to a model that was frozen a couple of years ago. And we will, as soon as model 2.0 is frozen, we will start working on a version 3.0 of our planet model, which will be based on the third version, model E3 as it's called, from the Earth side of the house, which will have different kinds of grid schemes. And the cloud physics has been completely overhauled, rewritten, which will allow us to do things like CO2 clouds or clouds on Titan much easier, because we do have a cloud development person that works with us that is paid to help us to do things with the model. So there's a lot that's going to happen. I suspect in the next year or two, we'll be adding a lot of functionality to the model in the next release that will allow people to do even more interesting things with the model. So Stephen's asking if there's a way to change planet_S0 to vary over time. I don't believe that we have a way to. You can easily stop the model and restart it. That's easy.
I was typing exactly that the moment you started speaking. Yeah, you stop the model every December, you change the I file for the planet S0, and then you run it until the next December and so forth, or whatever the time step that you want to increase. It will be a step function, but I don't think that you are thinking of any major changes from one step to the other. So.
Yeah, absolutely. Another thing that you might want to consider, for example, when you're thinking about a new planetary configuration is, again, if you can find a configuration that we've published that is similar, not only would you want to get our boundary condition files, but you might want to try to get one of our restart files if, for example, your land sea mask is the same. The advantage of that is that the model will come into equilibrium much faster. Instead of running thousands of years, you might only have to run a couple hundred years if you haven't changed the forcing a great deal. And so you could ask us, do you have a checkpoint restart file for this particular run that I could have? And we could provide that if we have it.
And by the way, now that you mentioned this, I think that part of the plan is to provide the restart file, an equilibrated restart file for every run that we support for Planet 2.0.
Yes.
So if you want to run one of our configurations, you don't even need the spin up, really, unless you change something in the physics. But you will be starting from somewhere that is closer to equilibrium rather than some code restart that might take thousands of years.
Yeah, absolutely. And if you're going to do parameter studies, say, of a certain kind of world, you want to keep those restart files around so you can use them to bootstrap your next run, for example. And again, save yourself tens, if not hundreds of thousands of CPU hours unnecessarily. Certainly something to consider.
A typical example, for example, is something that I have done for the Earth model. I wanted to make something like something like a perturbed parameter physics for volcanic eruptions. So what I've done is that I ran the model. I've done a 10-year spin up of the model, saved the restart file, and then started the eruption from that after that restart file, because the spin up for all cases would have been the same. So there is no reason to repeat that. Absolutely.
And if it's not clear what we're talking about, because we have given you a lot of information, this is a very easy thing for us to tell you how to do if it's not clear already, because you will have to change the AIC file for that, where you want to put the restart file, and you will have to change the iStart number in the model, and that will depend upon what you want to do exactly. And we can tell you, we can point you to the documentation, but we can also tell you how to do it.
It's really a 2-minute thing.
Yes, absolutely. Okay, any other questions? Now's your chance.
See any movement? Come on, guys, it's your opportunity.
Okay. That's right. Well,
yeah,
ending really means we can get to work. Go ahead, Igor.
Yeah, I guess just wanted to mention about Planet S0. I think it's not that difficult to put a dynamic one if it's really interesting for physics, as Steven just told about, like binary stars.
I think it should be straightforward to make it a function inside the model instead of just a number.
Yeah, I don't think it's a big deal.
Or even make it an array that you provide from the random. I mean, it will be uglier, but it's. I think it's possible.
Yeah, so it's one thing to have the starlight change with time, as Eric mentioned. Though for binary systems, there's a couple other things going on. You got the spectral distribution changing, the zenith angle change. You got other problems to deal with in Planet S now. So.
The problem with the binary stars is that you have two different zenith angles at the same time.
Yeah.
And then even if you assume that the two stars are exactly identical, so the spectrum is the same, so the relative distribution does not change with time, although the planet S not changes, you still have the two solar zenith angles to worry about.
Yeah, and to follow up a little bit on the circumbinary issues, one hindrance in this case with Socrates is because Socrates convolves the shortwave spectral files with the stellar spectrum. There's no straightforward way at the moment. It'd be a major, home renovation to make it so that Socrates is actually dealing with two stars. Say if you have a G star and a K star and M star is your binary pair. It's not obvious how that would be done with Socrates on the Socrates side.
Well, actually, I think Socrates treats shortwave and long wave separately. I mean, can you call them? Maybe you can call like shortwave twice for different stars.
I think so. Yeah, I mean Yeah, you probably have to call short waves twice, track the zenith angle of each star individually, and then load in two different spectral set of shortwave spectral files. So yeah, it could be done, certainly. It's just there's definitely a few number of moving pieces there to consider.
Yeah, and then even if you do this, you solve the radiation issue, but then you have to worry about the rest of the model wherever it needs solar zenith angle, say albedo or clouds. It's very intrusive.
It's a big problem.
Yeah,
It's a big problem to solve.
we're happy
It's
to
not
get
on
it
our,
from a
it's not on
user.
our horizon.
Yeah, so if a user
Yes,
does that,
exactly.
we're happy to get it.
Exactly.
That's where you need the object-oriented approach, because then you just create basically 2 instances of radiation or 2 instances of albedo, and everything is supposed to work just out of box.
Yeah, for an 100% object-oriented code. Yeah.
Yeah.
Which we are very far from.
Looks like that's it for me.
Okay, good. All right. Well, thank you all for joining us, and we'll be back here next year, assuming the coronavirus hasn't gotten worse.
Yeah, thanks, guys, and you know where to find us.
Absolutely. Okay, and I'll talk to a few of you